At this site, there is 250 people working. The site is up and running 8,760 hours per year. But we only work 2 shifts. The whole night shift is unmanned. And in order to be successful with unmanned production, you have to have a very stable process. Another extremely important thing for us in Gimo is sustainability. And one of the things that we monitor is energy consumption. And currently this site consumes around 56 to 58 megawatt hours every single day. We have been a customer actually to CGTech for almost 10 years. And the reason for that is that we are really keen on getting stable processes. We would like to run as much simulation as possible. The worst thing that can happen is if you have a crash. And since we start using Vericut, we have no crashes. If you have a crash, the machine is standing still and you can't produce pieces. As I said, this plant needs to be up and running 8,760 hours per year, and then all the machines need to run 24/7. For us, collecting data, getting numbers, basing all our decisions out of facts is something we really want to do. And when we have the data, we want to utilize the data, and that's exactly what we have been doing with this project.
Vericut is there essentially to eliminate as much as possible program prove out. So your programs are proven offline before we get to the machine. Then secondly, we have our product called Force, and this is here to reduce our program time. Now obviously this relates to less spindle time, less motors in use, less coolant pumps in use. So what we did was taken one project on draw production. Sandvik Gimo have got a lot of sensors on the machine, so we can actually quantify the kilowatt output saving. So we're not just reducing our cycle time, we're obviously having a net effect on the kilowatt reduction, so therefore we're more sustainable with the software.
We can monitor the energy consumption from the machine, from the compressed air, high pressure pumps, and so forth. If we can continue the rollout of this optimization software throughout our production, we can achieve huge savings on cycle time and on energy consumption.
The purpose of this exercise was on one machine. So we wanted to quantify the savings, not just in cycle time, which the software is here for. We want to quantify the energy saving on this one machine. Okay, so if we're paying, for example, 28 cents in euros, 28 cents per kilowatt, and we're machining 3 pieces per hour. Now the net effect of that here at Gimo is huge. We have 400 machines on site. To provide transparency, the calculation was based on machining 3 drill holders per hour, with the machine running 16 hours a day. Comparing data from before and after Vericut Force optimization revealed a 0.59 kilowatt hour saving per workpiece, or a 15.3% reduction. This equates to a saving of 1.77 kilowatt hours per day and more than 10,000 per year. The financial savings would translate to €3,000 per machine per year. This outcome shows that a typical machine shop running 10, 20 or 30 machines can achieve savings up to €30,000 per 10 machines, €60,000 for 20 machines, or €90,000 on 30 machines per annum, based solely on reduction in energy consumption. Further savings will result from faster cycle times, extended tool life and increased capacity.
The result out of this one machine project has been really amazing. And you can imagine if we would implement this on just half of those machines, the financial and sustainable impact will be huge.